I hope you don't need a calculator for this. This is some people with it like a security blanket, and I understand that, but there's help for you somewhere. Brooke?
I was just gonna say the answer, but I'll let everybody else say. I just wanted to be confident that I could do this.
All right.
So I asked you to do it.
What you get?
18.
Yes. I have only one component that's common to both of them, I hat. The i's are the only thing that'll survive, because I dot j is 0, k dot I is 0, k dot j is 0. The only thing that will survive is the 2 times 9, or 18. Now, one other generality on dot products, and then back to cake. I have some generic vector A, and I'm doing a dot product with itself. What is that equal to?
1.
No. If they were unit vectors, yes, but they're not unit vectors.
And yeah, so a squared.
Yeah, it's a squared. Doing plug and chug here, it'd be the magnitude of one times the magnitude of the other times the cosine of the angle between them. And any vector, what is the angle between any vector and itself?
1 or 0.
0.
So that's equal to 1. And so what I'm just left with is a squared. So whenever you're squaring a vector, this is sort of awkward notation here, but whenever you do a dot product with itself, you basically end up with a square term of the magnitude. And so typically it's written this way. So now, let's go back over here. So from this first equation here, or from the derivation of it, I have VF minus VI is equal to AT. From this equation right here, I have VF plus VI is equal to 2 delta x times time. So if I just solve for the numerator here, I multiply by 2, divide by time, you don't end up with this, you end up with time on the bottom. There we go. So solving for the numerator here, multiply by 2, divide by time. This is just a scalar times the vectors, just like distributing. 2 times 4i hat plus 3j hat is just 8i hat plus 6j hat. So, multiplied by a scalar is just the same stuff that you had been doing. All right, so I have this situation right here, and now I'm going to do a dot product. I'm going to do a dot product between the left sides and the right sides. So I have VF minus VI. Put a little gap there because I put something right there just a moment, is equal to AT. The math people tell me as long as I multiply both sides by the same thing, it's still legitimate. So I'm going to multiply the left side here by VF plus VI. And multiply the right side by what that is equal to, which is 2 delta x over t. Well, time cancels out. Because in physics, we have the power to make time go away. So I'm left with 2a dot delta x. And over here, well, I'm going to distribute, or FOIL. So I have VF dot VF plus VF dot VI minus, so it's inner VI dot VF plus VI dot VI. So just FOIL, first, outer, inner, last.
Shouldn't the last one have a negative in it? So like plus VI dot VI?
Yes, thank you. Anything else?
I think that's.
So let's simplify it. It does not matter what VI and VF are. This bit right here, since the commutative property holds, it doesn't matter the order in which I do this dot product, those are gonna cancel out. Let's write a little note here, VF dot VI equals VI dot VF. And so now we're left with VF dot VF, which is simplified as,
Just, yeah.
and VI dot VI,
Negative VI squared?
yeah, with the minus sign in front there. So I'm left with VF squared minus VI squared is equal to 2A dot delta X. Or solving for VF, VF squared equals VI squared plus 2A dot delta X.
Is that our fourth?
And that's the fourth one.
Okay.
And now it's time to use them. So as you're reading a problem, if you see the term constant acceleration or uniform acceleration, your brain should immediately click and go, kick. It's probably gonna use one of those. I did something with the eraser. Oh, dropped it or threw it. We're gonna start out with that one, and I'll slowly add things as we go. Whenever you're given one of these problems, you're gonna be using one of those formulas. I'm gonna talk about a process to go through when dealing with these. Some of you who've had physics before, potentially looking at this and go, yeah, I need to know immediately what to do. That's fine. I have had students who look at this and they go, I have no idea which formula I'm gonna be using. So sort of going through a process now where you can sort of come up with what formula do you use. There's basically 5 quantities here. There's delta X, VI, VF, A, and T. I'm going to put a little plus sign in front of the 20 meters per second to emphasize that it is a velocity and not a speed, not just a speed. If I know 3 of these things, I can find the other 2, assuming constant acceleration. So let's figure out what we do know. In the problem, what do we know?
We know
We know, yeah. Energy velocity.
acceleration.
Yeah, acceleration. Because acceleration is negative doesn't mean it's slowing down.
Only because the initial velocity is positive.
Right.
But it won't slow down the entire time.
Okay.
I think they're, you know,
Any other time?
nobody called me on that.
The meters per second squared.
Yeah.
I will in the video later.
Thank you.
I will.
Just make sure, what a buffoon, I can't believe you left the 2 off. And time,
Is 11.
11. We also know our V final, don't we? Because
what were you thinking?
it says it accelerates uniformly, so
Yeah.
after the 11 seconds, we know that the V final is gonna end up being 13.
What?
No.
Because our, well, oh, it accelerates.
It'll
Oh,
be
never mind.
negative 57 meters per second, but
Right.
we'll get there.
Okay,
Basically, what I'm starting with is just what's in the problem itself.
okay.
Now we can calculate other things. All right, so once you've identified the three things that you do know, the next thing is what are you trying to find?
Displacement.
So we want and VF is not part of this. We don't know what VF is, and we're not looking for it right now. Which means I want the formula that doesn't have VF in it.
So VIT plus 1/2 is.
That's the one. So we end up with delta X is equal to 20 times 11 plus
1/2.
1/2 negative 7 times 11 squared. Do not square the 7. So 220 minus whatever that is. Just shy of 400. Yeah. 420. What is this?
Yeah, negative 423.5.
No, I didn't track units as I went, but what units do I have to put on at the end? Because this is my answer. I think somebody said it.
Yeah.
What does the negative mean?
That the displacement is like negative from the starting point. No. Yeah.
Yeah, so I have some starting point here. I'm just gonna arbitrarily, have it, choose right positive. So the car's moving in this direction, it stops, comes around, and after 11 seconds, it is 203.5 meters to the left, or on the negative side of where I started. Final velocity. Well, at this point, I know displacement, so there's only one equation I should not use, and that would be this one, because that doesn't have VF in it. So to find final velocity, I can use any of the other ones. The first one seems the simplest, but there's nothing wrong with using the others. And so VF is 20 plus negative 7 times 11.
Meters per second.
With a question mark?
Yeah, meters per second.
Okay.
I was skipping ahead earlier.
Ah, okay.
I was just thinking 2 steps ahead.
It's really trouble when you're unstuck in time and you start giving answers for different points. All right, so let's find VF using this equation here. We can do it, but we gotta be careful on that fourth one.
It's squared.
Yeah, because this is speed. This is my final speed squared, and I asked her what's the final velocity. So if using this will get us the right answer, but we have to think a little bit at the end as opposed to just the blind plug and chug and trust that we've done everything correctly. So using that last equation, I have VF squared is equal to 20 squared plus 2 times
11. Wait, sorry, negative 7.
times negative 203.5. Now, in a one-dimensional problem, you can get away with this with I just take the negative sign and stick them in there. In reality, I'm doing a dot product. My displacement ends up being to the left, given what I've written there. My acceleration is in the negative direction also, so the angle between them officially is 0, but this works. The two negatives will cancel out because the dot product is a positive number there. And so I get 400 minus, oh, I couldn't think of nicer numbers here.
I think it's 2849 for the
Yeah.
whole thing, just
2,849.
yeah.
There is no 0.5. Wait,
Oh.
No,
Okay,
you're right side.
2,449.
That's
Okay.
VF squared, and so
Okay.
VF, I'm assuming is 57.
It's
Oh.
49.48.
Hold on.
No, I got.
So-
Did you add?
I got
It's,
3,249 for,
Yeah.
VS.
Oh, y'all, sorry, I subtracted. Why did I subtract?
Well, that's with a minus sign there,
Why
but,
is it-
so this piece right here would therefore have to be 2849.
yeah,
All right, and so VF is 57. Which is true, my final speed is 57 meters per second, let's go ahead and throw that in there. But if you're doing that, you do need to think through it and go, wait a second, at that point, since he ends up over on that side, he's turning around once. In a constant acceleration problem, you're only turning around once at most. He's moving to the left, so then you have to think through it and go, okay, so my final velocity is negative 57 meters per second.
But speed would be positive, just direction.
Speed is indeed positive.
Okay.
speed doesn't deal with direction, it's just kind of like a number,
Yeah.
okay.
Now, it is possible to have negative scalars, but not with speed. Negative time you could have negative time, because that just means it happened before you started the stopwatch. All right, so we've used, well, we did that, and that. Let's extend it more. Now let's write in what we do know. So obviously, any other questions have to be slightly more manipulative than that. Not the right word, but better it is. Now I want to know is what is the distance traveled? In other words, delta x. So why is the answer not 203.5 meters?
Because it's not a vector. Wait.
No, that's.
You're not counting the other direction.
It's your displacement, it's not the total distance.
Yeah, the distance traveled, that's what the odometer in the car reads. If I end up dying where I was born, the distance I've traveled in my lifetime is not zero. Displacement is, but the distance is not. So we need to figure out this right here. How far does he move to the right before he stops? So at what time does he stop?
11 seconds?
Ooh, at 11 seconds, he's going
He's
negative 57
over
meters
there.
per second.
Yeah, never mind.
He stops in about 3 seconds.
Yeah, about 3 seconds, just shy. What would you use to find the exact number?
Sorry.
We know, what do we know? VI, VF, delta S, or X, A, and T. We know acceleration. We know initial velocity. What else do we know for this, to figure out the time it takes him to stop?
Time?
No, that's what we're trying to find.
Oh,
Not, I don't know, displacement?
Nope. That's what we're ultimately trying to find.
Right.
well, the only other value up there is V final.
And what is V final?
0.
Yes. This is a slightly different problem here. This is how long does it take to stop? Stop. V is equal to 0. That's
Okay.
0. So the first equation is the simplest. I end up with 0 is equal to, so 20 plus -7 times time. -20 is equal to -7 times time, divided by -7. And you get time is equal to whatever 20 divided by 7 is.
Justin?
1.857 seconds.
4. It
This
repeats
car is
itself.
going so fast.
Is that?
I said this car is going really fast.
That's about 45 miles per hour, and that's 120 something miles an hour.
Yeah.
So we know how far it went to the right, or in the positive direction. Oh, no, we know the time, so now let's figure out how far he actually goes to the right. You know, we have a choice of first, second, or third one. Probably the third one is probably the simplest one in this case, in my opinion, but actually, on a test or quiz, the simplest one is the one that your brain locks onto, and that's the way you're thinking at that moment. So plugging into the third one, I know that the displacement is equal to VI plus VF over 2 times 2.857, which is 28.57 meters. So he goes to the right, 28.57 meters. How far does he travel back to the starting point?
28.57 minutes.
Unless, of course, a rip in the space-time continuum. And then that. So the total distance traveled is 28.57 plus